I'm Kevin with Alliance Calibration, and here we've got a couple of multimeters. Multimeters are used to measure several different electrical properties. You'll see that this one is 5 digits, and this is a 6.5 digit multimeter. The number of digits that are displayed indicate the accuracy of the multimeter itself. Typical multimeters will almost always measure volts, ohms, and amps. Additional functions that can be found are things like capacitance, diode tests, transistor tests, frequency, a whole slew of other measurements can be done as well using these devices. Typical handheld multimeter like this will have some kind of rotary switch or button, something like that, to select what you're going to measure. In this case, it's set for volts AC. The little squiggle above the voltage is telling you that it's AC. And just as a quick example, we're going to set it to volts DC. We're going to connect our probes. The black one is indicated, that's common, and this connection over here, that's for volts and ohms and various other functions. The other two connections here are for amperage, and I just have a 9-volt battery that came out of something because it was about dead. And we see that our 9-volt battery is actually at 8.901 volts, hence why it was probably dead, because it's no longer 9 volts. If you were to measure amps, in this particular case, you can just take the measurement outside of the circuit. If you were to go and measure amps, you actually have to break the circuit and measure inside the circuit. So you would then open up somewhere in your circuit, connect your leads, and then you'd be able to read the amperage draw in the circuit itself. You may think that you blew a fuse in something, and this is actually a fuse from one of these types of meters. The way that you would check that is go to your ohms function, and right now it's showing overload because it's not connected to anything, and you're going to check, and it should be somewhere right around 0, and it's 0.2 something ohms, and that's actually the resistance of these wires. And we're going to check this fuse. Now, if the fuse were blown, we would see this overload, but the fuse is good, and it's reading about an ohm or two, which is about normal. Now, when we touch these together and we see that we have resistance in the leads itself, that can be problematic. To eliminate that, we use a different type of measurement called a 4-wire measurement. A 4-wire measurement uses the combination of amperage and voltage to produce a measurement. And this should already be set to my 4-wire. It should be showing overload. And when I connect these together, you'll notice we get 0 because it's compensated for the actual lead resistance. And if we were to go and measure a resistor, which I've got this little guy right here, we would find that he is right around 10 k ohms. And if we were to try to measure this same resistor here, you're going to find that he's right around 10 k ohms as well. However, you'll have that little bit of extra resistance from the leads present. Potential errors that come up when you're using a multimeter most frequently have to do with incorrect wiring. For instance, if you were to try to measure an amp signal from outside the circuit, as we would say, in parallel with the circuit, you're not going to get a correct reading. It has to be done by breaking the circuit and then taking that reading. Other common ones, like I showed, the 2-wire versus the 4-wire, can make a big difference in resistance readings. In this case, we're dealing with 10 k ohms. This is a very small amount compared to that, but if this were a 1 ohm resistor, and then I have that 0.4 ohms in lead resistance here, that can pose a pretty big problem at that point. As far as cleaning, storage, handling goes, these guys are pretty rugged. A lot of times they'll spend most of their lives living in the back of a pickup truck. I typically will scrub them down just with a little bit of denatured alcohol. It tends to get about everything off of them, and it doesn't damage anything. If you use isopropyl alcohol, it can mess up the screen sometimes. This type of device is designed to be portable. Storage is not a big deal. You can have it in your freezer, you can leave it in your oven, just don't get up over 350. Your lab grade devices, different story. This is really made to be left plugged in all the time. It's best for the accuracy, it's best for the overall functionality of it. It's not going to reach its peak accuracy until it's been plugged in for an hour or two. Whenever we calibrate one of these, we actually leave it plugged in for 30 minutes before we take any measurements. That's kind of key to these.